Hi, my name is Laura Scherer. I'm a waste management consultant and I welcome you to this video on waste hierarchies. If you want to know what this is, then you should stay tuned because I will be explaining the waste hierarchy as well as its logic for application. If you're already familiar with it, then this video might still be interesting for you because I will be also presenting some variations of it, like for example those that you see in the screen below. You should also stay until the end of the video because there will be a waste hierarchy challenge as well as some questions for reflection that will allow you to get involved on this topic. Just one note before we start, the following content was created for a webinar that I gave as a volunteer for a students association. If you're interested in learning more about waste management and the circular economy and looking for a speaker or volunteer to present some topics, please reach out to me anytime. All right, that being said, enjoy the video, subscribe if you like this content, and give me a thumbs up if you like the video. So here we see this archetypical waste hierarchy. It's like a triangle that's broad on the top and narrowing down to the bottom, and it usually has 5 steps. So you have prevention, then underneath that preparing for reuse or sometimes only reuse. Then you have recycling, recovery or other recovery often, and then you have landfill on the bottom. And so here my question is to you, has any one of you ever seen this picture or something like it? No? Okay. Yeah, it's something that is not that spread around, but you will see the value that it has. But before we go into the logic of the waste hierarchy and how you can actually apply it, we will see what the different phases mean. So on top is prevention. So it means if you have a waste or if you have something that should get disposed of or discarded that you do not want anymore, you should first look, can you use less material in design and manufacture? So even before it gets produced, can you prevent waste from occurring by having less materials? For example, bottles, the Coke bottles, they used to be much thicker. Now they made it very thin, and by this way they can already create less waste when the bottles become waste. You should also check, can you use less hazardous materials? For example, fridges, they used to contain chemicals that are very bad for the environment, then it got banned, and so now it's better. And obviously you should look, can you keep the products longer in use? Can you reuse it, either you yourself or someone else? And the same goes for companies. You know, can they use it or can another company use it? Then the next step, if all of this is not possible, you then look, okay, can I check it, clean it, repair it, refurbish it? Can I do it for whole parts or just spare parts so that it can be reused again in the same purpose that it had before or in another purpose? If, for example, you can just use a part of it and the rest is broken and you can still make use of that other part. If that also is not possible, you will check, okay, can I turn this waste into a new substance or product? Obviously, here we have very diverse recycling mechanisms for different products. We will try to go a bit into that later. And if you also cannot recycle it, you should then ask, okay, can I have another type of recovery? Can I create energy or materials from it? Here we have some examples listed. Anaerobic digestion, it's basically biogas plants. That's the process they use. It's kind of a fermentation, so without the use of oxygen. Incineration with energy recovery, it means burning the waste, but using the heat energy that comes from it and translating it into, for example, electronic current. Gasification is a process by which wastes are transformed into syngas that can then be used as chemicals or as a fuel. Pyrolysis is another process. It's basically if you break down organic components with much heat but without oxygen. And backfilling, what is noted here, means that you use the material as a filling material for other things. So you can't use it again at the same way it was used before, but differently. One example for this would be that in some countries, plastic waste, they're used to fill or to create higher volume for the pavement. So they mix it with the, I don't know what it's called, I think tar, and then they have a higher volume of tar that they can put out, but basically it's just stretched with plastic. But then you can't get the plastic out, so you know it's problematic, and after all it would be better if it were recycled. And then if that also is not possible, you will have a look at other disposal options, which are then often sadly landfilling, so just putting it in the nature, but obviously in a safe zone, or burning it, but without energy recovery. So you just burn it to get rid of it, basically. Yes. So, so when I, for example, in my consulting work, go about identifying ways to dispose of any new material or new waste that we have, this is also the logic that we apply. So first you ask, okay, can you keep it in use? Could somebody else keep it in use? Can somebody else, or you or somebody else, use it in another way? Like, for example, if we look at production processes, and if like some material goes out of it, perhaps you can put it back again into the production process, or you can check if another company can use this material. Then if that is not possible, you would then check, okay, can you check, clean, repair, refurbish it? So that's mostly the case for really products that have use, so less the production waste. And then after that, if that's not possible, you will ask, can I recycle the substance or the material? For organic waste, you will also check, can it be composted, for example? If that's not possible, you ask, can energy be produced from it? And can I put it somewhere where actually from the energy, from the incineration energy is recovered? Or can it be used as a filling material? And then if that's not possible, you ask, how can it be landfilled or incinerated safely? So the logic, the ideal would be obviously to prevent all sorts of waste and to not have them in the first place, which would also be the ideal of a circular economy. However, it's not really realistic because you have certain kinds of waste that are just very, very difficult to recycle, like for example, car tires. So there, it's difficult. However, you can see if you can prevent it, but then obviously you would have to start with the design phase. So if it's not possible to prevent the waste or to give it, to someone else or reuse it, then you will see, okay, can I prepare it for reuse? For example, if something is broken, can I repair it? If that's not possible, can I recycle it? And so on and so forth. So the goal of any approach of waste reduction is to keep it up or to get it back up, because the principle is that the higher you are in the hierarchy, the higher is the value that you have of the product. And so usually that also translates into costs. And here we are back at this economic aspect. For example, if there's a company that has a waste that has to be incinerated, incineration with energy recovery, it's quite expensive. So if you can manage to find a way of recycling it, it's probably less expensive. It is even more cheap if you find a way to reuse it. And sometimes the company, they can even get money from it. If they have the possibility to sell some old products or something that results from their production process instead of having to dispose of it as a waste. So that's the logic also here. And now we will talk about one example, your least favorite piece of clothing. So if you apply the waste management hierarchy to this, what would it mean? So if we think about preventing it, so first of all, you could just wear it, or you could just continue to wear it. But for example, if it's too small or too large, or it's not the style that you want to wear anymore, you could then consider giving it to a friend or donating it or giving it to a thrift shop or other. Because that would obviously be less cheap, or if you can sell it, you can even get money for it. Whereas if we think about the bottom of the pyramid, so the disposal, you will have costs. I mean, maybe not you, because I imagine most of you are still living with your parents, but your parents, they pay for waste disposal. Maybe you can ask them. When I was your age, I didn't know how much waste disposal costs. Now that I live alone, obviously I do know, but maybe you can ask your parents, like, how expensive is it even to dispose of our waste? So there you would have a higher benefit. If, for example, there's a hole in your in this piece of clothing, you could then see, okay, can you stitch it, or can you resew it to a different size so that it can still be worn as a piece of clothing? So here we often make the distinction between same purpose or different purpose. So in a different purpose, for example, if the hole is too big, or I don't know, if the arm has come off completely or whatever, you can then still use it in a different purpose, for example, as a cleaning cloth. Then there still is some value of it, because like, it's a use value. Maybe it's not a financial value, but a use value. If that's not possible as well, then you could think about giving it to textile recycling. So textile recycling basically works in the following way nowadays. So, you know, the facilities that collect the textiles, you know, if you give it to your communal box or whatever, obviously they will first see if it's in good shape, because then they can sell it and export it to other countries. But if it is broken or something, they can then continue and do first color and material sorting. Oh, there's a typo in there, sorry for that. So basically they will, sort according to color, and for example, if it's synthetic cloth like polyester, or more natural materials like cotton, then buttons and zippers are removed, the whole cloth is shredded, and then they have to mix it with virgin fibers. Why? Because when you shred something, the fibers get very short. And if you would only use the recycled materials, the fibers would be too short, so it's not possible to make a stable yarn. So they have to mix it with virgin fibers because they're longer, and then they can get a stable enough yarn to then make recycled clothing out of it. So if that's also not possible, I mean, obviously this is often out of your scope of decision, because it's difficult for you to research the textile recycle, but now the industrial or the professionals that would then continue with this garment, they would then check if it is possible to incinerate it with energy recovery, because often that's also less cheap than without energy recovery. And then if that's also not possible, we would opt for incineration without energy recovery, because that's still, in my point of view, better than landfilling it. Okay, so let's sum this up about the archetypical waste hierarchy. So we have the 5 levels from prevention to disposal, and the breadth indicates the desired proportions in the real application. So it's a normative scenario, so it means that it should be that way, that we prevent most of it and have the least disposal. And the following the hierarchy is desirable from an economic as well as an ecologic standpoint of view, because the higher the value, often the economic value is higher, but also for the ecology. Okay, so now we will have a look at different variations, and then you will see how different ways of applying the pyramid, basically what the differences are. So here's one that is from the EU Waste Framework Directive. And that's basically the European law that has all the infos on waste management within the EU. And so the waste hierarchy has also become popular through this directive. And here you can see there's a distinction between waste and non-waste. And why do they do it? It's because actually when it comes to regulations and really laws, it's important to have this distinction, because, for example, for transporting wastes, like the logistics part of it, you need different certifications if you want to transport waste. Obviously, because the drivers, they have to know how to handle the waste. You know, for example, if there are also hazardous substances among it, you know, you have to. There are some hygiene regulations and so on. And so basically the definition, if something is a waste or not a waste, is in the practical context quite important for the business. And for the rest, it's mostly the same. However, if we look at another example, so here we have the zero waste hierarchy that was developed by Zero Waste Europe, we see that it's already a bit more complex. So let's have a look at it in detail. We also have the shape of the triangle with the broadest on top, and on top it says refuse, rethink, redesign. So refuse what we don't need and change the way we produce and consume by redesigning business models, goods and packaging in order to reduce resource use and waste. So here it addresses clearly the design aspect of it. So already before you produce something, you should keep in mind what happens with it at the end of life. So when the consumer is done with it, for packaging, for example, when the goods, let's say, food packaging, you know, if the goods are eaten, what happens with the packaging? Can you reduce it? Can you have no packaging or something like that? And the second stage, reduce and reuse, it says minimize the quantity, toxicity, and ecological footprint of consumption. Use products or components that are not waste for the same purpose for which they were conceived, or repurpose them for another use that doesn't reduce their value. So here this would refer to this example of same purpose versus different purpose reuse that we saw with the garment. You know, you can use it as the garment that you can wear on yourself, or you use it as a cleaning cloth to have a different use. And then we have preparation for reuse. So that's quite similar to the one that we've seen. Check, clean or repair products or components that have become waste so that they can be reused without any other pre-processing. So what is very interesting here is that we have two stages for what before was called prevention. And then here we also have this preparation for reuse. And then we have some more levels that are then linked to the recycling. So the next three steps are linked to recycling. And the first one is recycling, composting, and anaerobic digestion. So it's a high quality material recovery from separately collected waste streams. And it's very important to note the separately collected waste streams, because how does it function in practice? If you want to recycle something, like for example, plastics, usually what the plants get is post-consumer packaging. It means that when we as consumers are done, usually we put it in a bin. If you were in Germany, you probably know the yellow sack or the yellow ton. So it means that all the packaging goes in there. And it can be different kinds of packaging. So for example, different sorts of plastics or aluminum or other. Obviously, a plastic recycler can't really deal with it if there's aluminum and sometimes maybe cardboard or other types of packaging in it. So it is very important that these post-consumer wastes are separated before. And only if you have really clear waste streams, they can then be recycled. So if that is not the case, then we have to have the material and chemical recovery first. Actually, here it says technologies to recover materials from mixed waste and discards from sorting processes into new building blocks for high quality applications. So here, technologies to recover materials from mixed waste. So that would be a sorting process, basically. So you have to have this step before you can, or actually this step, a sorting, will allow you to go up one level in the waste management hierarchy, and then you can do recycling. So here we already have this value creating process and this logic of moving up the steps of the waste management hierarchy. And but if you have a mixed waste stream where you cannot make clear waste streams out of it, where you cannot sort it, then you have to see how you can recycle it differently. And then the next step would be residuals management. What cannot be recovered from mixed waste is biologically stabilized prior to landfilling. So here you have basically already given up on the idea of being able to recycle it, because it's just all mixed together. You cannot separate it. Maybe it's also different materials as such, like the tires, for example, that we've seen. So there, the main aim is to then make sure that if you landfill it, and if, for example, it gets into contact with the environment, that nothing bad happens. Like, for example, if you have hazardous substances substances, that you organically inactivate them so they don't cause harm to the environment. So here we see that actually these 3 steps are what we have seen before as recycling. So this hierarchy is much more detailed on how you should basically go on if you want to discard of a waste. So it's a more detailed description of it. And what is also very interesting about this is that down here, all the other types of recovery or disposal that we have seen before are deemed just as unacceptable. So here it says options that don't allow for material recovery, have high environmental impact, and create lock-in effects that threaten the transition to zero waste. And so here they also note waste to energy incineration, co-incineration, plastic to fuel, landfilling of non-stabilized waste, gasification, pyrolysis, illegal dumping, open burning, and littering. So that's basically many of the things that we have seen in the other hierarchy before. And for example, waste to energy incineration, so the incineration with energy recovery. In some states, it is even seen as recycling. So here we see that in this hierarchy, there is also a value statement implemented. So the values that are promoted by Zero Waste Europe are integrated in this hierarchy, and they say clearly, all of this is not acceptable. We really have to focus on recycling and on preventing. But the views differ. So it's just that you know, depending on who releases information, and that's general for all types of information, this information is sometimes infused with their bias or their point of view, basically. So now we will have a look at a different visualization of a waste hierarchy, and that is the food and drink hierarchy. It is developed by the UNEP FAO, so the United Nations Environment Program, Food and Agriculture Organization. And so before we discuss it, my question to you is, what is different in this hierarchy here from the ones that we have seen?
Recycling is not good. Like it's considered like a waste.
Yeah. It deals with waste. Yeah. Can you see any other distinctions?
There are not 3 gaps, there are only 2.
Yeah, they distinguish also between basically non-waste and waste, a bit like in the EU waste management hierarchy we've seen before. Yeah. And can you also read what is written in there, or is it too small?
There is also optimization, which wasn't over there in the first one.
Exactly, and that's a very interesting point, because if you have a look at the optimization here, there are 2 levels. So the first one is redistribution to people, and then sent to animal feed. And this is because here, basically, this hierarchy refers to food and drink. So we have a specification already onto a specific type of waste. So before it was very general, and here we're going specifically into food and drink. And here it gives more options. So for example, if we have food or drink, obviously we have the possibility to give it to people as a means of donation. So for example, if we think about a supermarket that has purchased too much food that they cannot sell if it's close to the expiry date, or even often it's also the case for fruits and vegetables that are not that pretty anymore, before they just throw them away, many supermarkets have some donation schemes in place. Or like in Germany, for example, you have the Tafeln. So these are organizations that will then collect all this food from the supermarkets that the supermarkets cannot sell anymore, and then they will either donate or give it for free, or sell it for a very cheap price to people that are in need. So that is very interesting. first of all, from the philanthropic perspective, because actually it allows those people that are in not such a good economic situation to access food more cheaply. But also from the perspective of a supermarket, it also makes much sense, because with a donation, they don't have to pay anything. If they have to dispose of it as bio-waste, for example, if they bring it to a biogas plant, they will have to pay for it. So here again, we have that it makes sense ecologically, here also socially, and then also economically. And then sent to animal feed, this I think is also a very interesting option for food and drink. And this is something that, for example, bakeries can do. You know, bread can be either can be processed so that pigs or cows can eat it, or chicken, or even if we think about animal feed, we can even go as far as think about insects. Nowadays, there are more and more companies and startups that go into the field of reducing organic waste, and not just bread, but also fruits and vegetables, for example, and others, by feeding it to insects. And then the insects can then be used to produce some chemicals or proteins or other things. So that's something that is really in development currently in many countries, and what I think is a very interesting approach, because you know, insects, they can actually go into the packaging much easier. Most of the fruit and vegetable packaging, they have little holes, and insects can get through. And if you would bring packaged fruit and vegetables to a biogas plant, it would first have to be unpackaged. And that usually is done with depacking machines. But it's not such a good solution, because even from what you get out, the organic material, it contains a bit of plastic, and then it goes to the biogas plant, and also the plastic or the packaging part that comes out of a depacker, it will have much organic material in it. So it's not clean plastic that you can easily recycle. But if you use insects, they will just go inside, they will eat everything out, and then you have a more clean plastic packaging at the end. So that's, I think, interesting. Yeah, and then we have recycling. And here we have the anaerobic digestion. So it's the biogas plant. It's a fermentation process without the use of oxygen. And then we have composting, which is basically also a kind of, it's an aerobic digestion. So it means that oxygen is involved in the process. And now the question is, why is anaerobic digestion above the composting? It's because if you have the anaerobic digestion, you get the biogas from it. So with that, you can make electricity, and you also have a substrate, you know, that you have basically like something that you can use as a fertilizer afterwards. So you have two output products, the energy and the fertilizer. And if you have the composting, you just get the substrate. You don't have additional energy. So that's why it is seen as of higher value, because you have two outputs. So yeah, exactly. And then the other parts are basically like the ones we have seen before. And as I said, this is the one of the United Nations Environmental Program. So now we have still another type of visualization. So here again, my question to you, what is different with these visualizations than the ones we have seen before? Not all at the same time. If you take a look, can you see any differences?
Yeah, so the pyramids are turned around. So on the left, we have a big block of red and a small top of green, and on the other one, it was turned around. And on the right, we have the same pyramid, so turned around, but the red part stays small and the green part stays really big.
Yeah, exactly. So that's the main difference. So first of all, yeah, they turn around, and they also use different logics. Like if we look at the left one, we see that disposal is on the bottom and it's the large part, which is good as it's red. So it basically means, yeah, that's the bad, that it's, yeah, not the favorite option. So here we're not in the normative view anymore. So it's not, okay, we should have the highest part for the disposal. No, I think that's more the current situation. So at the moment, we have most disposal and least prevention, and that's not good. But so just what is always important is that the logic is right. So here the logic is right, but it's a different logic than in the hierarchies that we have seen before. On the right side, the logic is the same like before. So disposal takes the smallest part and is least desired. And refusing and reducing is also the largest part, and it's in green. So here it's just that it is basically turned around. You also see that there's some additional information like donate and segregate, or investable and sustainable. So I think it's very interesting because it shows the flexibility also of the concept, and there's just not just one view, like also like in many parts of life, or as we've seen, there's never just one right or wrong in cultures, and also with this kind of visualization. It's just always important that the logic is right. Here it is right, but it has different meanings. And then we also have, very crazy ones, like this one here, for example, which I also found on Wikipedia. I won't go into detail on this one. You can have a look at it. It's even more detailed. It even gives more of an orientation of what is to do in which case. And you can see there's also the reduce, reuse, and recycle aspects. Like here, reduce, reuse, recycle. And so I invite you warmly to take a look at it afterwards and try to understand it, what it means and how it can be applied. And we will go on to the last hierarchy that we are discussing today. It's also by the United Nations Environment Programme and it's from the Global Waste Management Outlook. So here again, my question to you, what is different in this one from the ones that we have seen before?
They distinguished between controlled and uncontrolled disposal, which wasn't a factor in other pyramids.
Yeah, exactly. And I think that's actually a very good visualization that they've chosen with the leak that basically spills all around. Because in reality, that really is a problem, the uncontrolled disposal. And sadly, nowadays, much of the waste are disposed of uncontrolled. This is, for example, the case for the ocean plastics. How do they get into the ocean? It's because all the other steps have failed. Everything has failed, and that's why it goes into the ocean, it's in the environment, and that's what we definitely have to prevent. We definitely should see that if waste occurs somewhere, that they are controlled, that they are disposed responsibly and controlled. And this is why we need to get active to prevent this uncontrolled disposal, because we already have so much waste in the nature and in the oceans. It's really something that we should get involved. Welcome back again. As promised in the beginning of this video, here comes the part that will allow you to get involved. I have prepared some questions and also a challenge for you, and let's have a look at them. So the first one would be, which one is your favorite variation of the waste hierarchy and why? Please leave it in the comments if you have special feelings or more information on one of them. We would be exciting to know. Then research further variations of waste hierarchies online and compare them to the ones that you have seen in this video. Yes, these are just some examples of the ones that I have found online. Perhaps you can find other ones that will also be interesting for the people that are watching this video. Can you think of another product and research how it cascades through the waste hierarchy? We would be interesting to know. How could it be prevented to go to waste? How can it be reused? How can it be recycled? Please share it with us. And then the challenge, design your own variation of the waste hierarchy and post it online, for example, on Twitter, on my Facebook page, using Circulora and hashtag waste hierarchy challenge. Don't forget to include Circulora, because I would like to do a best of video with all of the contributions. I'm very excited about it, and if you like this video and want other people to know about the waste hierarchy, please share it or get in touch with me for further discussion. All right, that being said, I still wish you a nice day and hope to see you soon. Bye bye.